We are starting lesson 1.3 today, compare and order real numbers. And the question that we're thinking about today is how can we compare and order rational and irrational numbers? We got a little taste of this on a couple of the homework questions from the last assignment, because like that one where you had 2.8 repeating and 2.9 repeating and we had to fit a number in between them. That's kind of what we're talking about today when we talk about ordering numbers. So how can you understand the value of rational and irrational numbers and how they compare to one another? So by the end of the lesson, we want to be able to compare and order rational and irrational numbers. All right, so here we go. Number one. Courtney and Malik are buying a rug to fit in a 50 square foot space. Which rug should they purchase? And explain yourself. So, let's talk about it. Buy it too big and then cut it down to the size they want.
Yeah.
You are not going to be the person I hire to decorate my house. All right. So that's a thought, but we'll not follow that line of thinking.
Okay.
So, how would we decide which one of these rugs would fit? Maybe you got to do a little math.
Maybe.
Okay, which one of them is going to be the easiest?
My idea.
I would do the first one.
Okay, the first one's pretty simple. What is the area of this first rug right here?
49.
Okay, so 7 times 7 equals 49 square feet. Okay, will that one fit in their space?
Yeah.
Yeah, it will. Okay, Charlie?
Easiest would just to be take measurements.
Yeah, I mean, we got to do some measuring, but they're at the store. Maybe they don't have the tape measure with them, so they got to just read the measurements on there and then figure out if it'll fit.
The
And
6 times 8 would be 2.
okay, so 6. If we look at the third rug, 6 times 8.5, that comes out to be 48 and a half again is 51. That comes out to be 51 square feet, I believe, if I did the math right. So too big, right? We can't do that, so we're going to cross this sucker out, even though it's pretty, and it might be the one my wife wanted. It's too big. Sorry, honey, it won't fit. Okay? Now we got this round one, and we got to think about whether or not we can fit this round circle rug into our square space. Is it going to be too big or too little? So we got to find the area of this rug. Now, wow, second hour couldn't help me at all with knowing how to find the area of a circle. Does anybody in here know how to find the area of a circle?
No.
Bryson?
So you start from the middle and you measure from one side to the other side.
From the middle of the rug to the side? Okay, what is that called?
A pie chart.
A pie chart?
You said, yeah.
From the middle to the edge of the rug. That's it. We do need that measurement. We sure do. That's the diameter is not from the center to the edge. The diameter is from edge to edge. Remember what you call from the middle of the circle to the edge of the circle?
Circle.
That's the perimeter of the circle. That's the distance around. That's good. This is where we got stuck second hour too, so that's all right. This has been a while since we talked about circle parts in math for you guys, I guess. It starts with an R. Radius, there you go. So that's the radius of a circle, and we need that measurement to find the area. So the area of a circle is pi, that magic irrational number that we use in some formulas, pi times the radius squared. Okay? And so what's my radius of this circle? 4. If the diameter all the way across is 8 feet, then half that diameter just from the center is 4. So I would need to do area equals pi times 4 squared. And if we had a calculator, which we do right here somewhere, we can do, all right, so what is pi? Well, I've got a pi button. So pi times, and what is the radius squared? So 4 squared. 4 squared would be 16. So pi times 16 equals, oh my goodness, that's a long number. But remember, pi is an irrational number, right? So it goes on forever. So that's why this answer goes on forever. 50.27 square feet is what we would say. And whoops, I gotta go back to where I was, which is over here. Okay, 50. So this equals 50.27 feet squared. Okay, so what about the circle rug?
Too big.
Too big or too little? It's too big, even though it's closer to 50 than this one is, right? But it went over, and so if we got that, we'd have to follow Riker's advice. It's too big, we'd have to chop part of the edges off. We could just kind of roll it up at the edge. It wouldn't be very much too big, but it'd be a little bit too big. And then it's a trip hazard, and somebody would sue us when they fell over in our house. Okay, so we're not gonna get the too big
Do
one.
you really do that?
You never know. So
That's a real.
how did we decide, down here at the bottom, how did we decide which rug Courtney and Malik should purchase? Well, we found the area of each of the rugs, and we picked the one that wasn't too big. That's how we decided.
Boom.
All right, so there you go. Now you guys know how to buy rugs. Okay. That's a good little warm-up question for us as we get started. Oh, look, a video.
Yay.
Okay.
Something to waste of time.
Yes.
I'm gonna get by time.
Here we go. Oops, I gotta plug in the speaker here. Okay.
How can you compare and order rational and irrational numbers? Think about this question during the lesson. Darcy wants to add this ribbon along the diagonal of the rectangular flag she's designing. Does Darcy have enough ribbon? Here's what Darcy knows. The flag is 7 feet wide by 5 feet high. And Darcy has 8 5/10 feet of ribbon. 7 squared plus 5 squared is 74. So the diagonal on the flag is the square root of 74. Darcy needs to approximate the square root of 74 to compare it to the length of ribbon. Why?
Why does she need to find the approximate value of the square root of 74 in order to compare it to the 8.5 Riker? Yeah, see if she's got enough ribbon. I kind of asked a previous hour, if he understood how they got the 74, and nobody did, so that tells me we've got a future lesson coming up on Pythagorean theorem, which is a fun lesson, series of lessons we'll do, but it's later in the year. So, yeah, so don't worry about where the square root of 74 came from. It's the correct number for now, and we'll get to that later in the year about how to find that number. But for now, why do you think that we're using the word approximate value of square root of 74, Emery?
Because it's irrational, so it goes on forever, and we just need to know if we have enough.
That is a perfect way of explaining that. This is an irrational number, so the decimal goes on forever, just like when we saw in the calculator a minute ago, that pi goes on forever and ever. So we're just gonna round it to get close enough. All we gotta do is see if we've got enough here. We don't need 47 decimal places. We just need the first one or two, right? And so once we have it rounded that far, then we're gonna be good to go. So let's see how they approximate it. We're gonna do, we'll talk about his solution and how he finds it here in just a minute.
74 is not a perfect square. So the square root of 74 is an irrational number. Therefore, you need to use a decimal approximation to compare it to 8 5/10. So Darcy can use a number line to approximate the square root of 74 using perfect squares. Because the square root of 74 lies between the two consecutive perfect squares 64 and 81, the square root of 74 is located somewhere between. Which integer is the square root of 74 closer to?
Okay,
Select
so
your answer.
at this, I really like where we're at so far with this video. This video is really good up to this point. Does everybody understand what he meant when he says it's in between two perfect squares? So 74 is not a perfect square. The one below it is 64, which is 8 times 8. And the one above it is 91, or 81, which is 9 times 9. So-
it's the same with the first one.
So 74 is somewhere in between those two perfect square numbers. Okay, now is it closer to 64 or is it closer to 81?
80, closer to 81.
It's closer to 81, which means the square root of 74 is gonna be closer to 9 than it is to 8. That's really good reasoning. And we need to be able to do that for sure in this lesson and in future things that we're gonna be doing, okay? So you're right.
Because 74 is closer to 81 than 64, the square root of 74 is closer to the square root of 81, or 9. We don't know exactly where, just that it's closer to 9 than 8. Now that she knows the square root of 74 is between 8 feet and 9 feet, can Darcy tell if she has enough ribbon?
Does she know at this point if she has enough ribbon or not? If she knows it's gotta be closer, if she knows she's got exactly 8.5, and she knows her answer is closer to 9 than it is to 8, can she pretty well figure out? She probably has a pretty good guess that she doesn't have enough. Now, he's gonna go through some steps so that he can narrow it down and get closer. We'll talk about his steps, because I've got, it's okay, it's good math, it's just tricky.
Darcy needs a better approximation of the square root of 74. She can get a better approximation by squaring decimals between 8 and 9, then comparing them. Darcy squares 8 and 5/10 and gets 72 and 25/100. That's too low, so she squares 8 and 6/10, which is 73 and 96/100. That's really close to 74. Darcy is disappointed because the length of the diagonal, the square root of 74, is about 8 and 6/10 feet. She doesn't have enough ribbon.
Okay, so here, let's stop right.
74.
Okay, let's stop right there. Do you understand what he's doing? He's thinking, okay, she knows it's somewhere in between, so she took her 8.5 and she squared it, and that would be 72.25. Well, that's less than the 74, and then this one, 73.96, was really close. So her length, she really needs 8.6, or actually just a little bit more than 8.6, and she's only got 8.5. So she knows now that she's got too little. Here's my problem with this method. What did she do to square 8.5 and 8.6? Do you think she did that by hand, or did you think she used a calculator?
Probably by hand.
I'm using a calculator on those. And if you're gonna use a calculator anyway, why are you using the calculator to do that, rather than just using a calculator to hit the square root button? Putting in 74 and hitting the square root button is harder than doing this. But so, if we're gonna use a calculator, and we will we're gonna use a calculator, that I'm gonna be okay with that. Like on your assignment, I'm never gonna send you home with an assignment like this and tell you not to use a calculator, because that's just inviting you to cheat, and I'm not about that. So I expect that you're gonna use calculators on your homework. But I need you to be able to do this step back here.
Because
Okay.
74 is closer to 81.
This is the part that I want you to be able to do. You need to be able to take this number and find the two perfect squares on either side of it and tell me which one it's closer to, okay? That part you really don't need a calculator for, especially when these numbers are under 100, because we should be able to figure out all the perfect squares that are under 100. All right, so let's do this one real quick, and then we'll wrap up for today. So between which two whole numbers is the square root of 12? So what two perfect squares is 12 in between? What's the perfect square that's below 12? 3 times 3 is 9. And so 9 would be the one that's below 12. What's the one that's above 12? 16. So 12 is in between 9 and 16, which are both perfect square numbers. Okay, so square root of 12, square root of 9 rather, is less than the square root of 12, and the square root of 12 is less than the square root of 16. So what two whole numbers go here?
Just
Square root of 9 is 3, square root of 16 is
4.
4. So the square root of 12 is somewhere between 3 and 4. Now, is it closer to 3 or is it closer to 4?
Closer to 4. Or 3.
Is 12 closer to 9 or is it closer to 16?
9.
It's closer to 9. So if we were to put it on a number line, we would put 3 here and we'd put 4 here. The square root of 12 is going to be a little bit closer to 3, right? Square root of 12 is going to be somewhere closer to 3 than it is to 4. All right, that's what I want you to be able to do. All right, if we get tighter than that, if we get closer than that, that's where we're gonna break out calculators, okay? But this is the skill I want you to have. All right, that wraps us up for today, and we'll pick up there tomorrow. Oh, perfect timing.